Hey everyone, Natasha here. Excited to guide you through a mixed designed ANOVA using R. All right, so let's get started. To follow along with this video, I need you all to make sure that you download the QMD file from my GitHub that's labeled Mixed Designed ANOVA. And how you can all do that is once you get to my page here, go ahead and select the code button. When you do that, a drop-down menu will fall. And what you all should do is download the zip file. Once you download that zip file, it will go to your downloads, and then you can move that folder that you have just downloaded from my GitHub onto your desktop. And this will make things a lot easier. Okay. And then from there, go ahead and if you could, then start up your RStudio. Okay, well, that is starting up. A couple things that we are going to do here. We are going to expand that window just to give you lots of space. And first, you should start a new R project. So what you need to do is navigate to that top menu bar, the RStudio bar, go to File, a drop-down menu will fall. Then select New Project. From New Project, please then select from the New Project window, New Directory. We are setting up a directory. This directory is going to be a folder where everything is hubbed, everything is stored, including your new script file along with the data that we are going to be using. So go ahead and then select a new project. In that directory name, go ahead and type out mixed ANOVA and then go ahead and select browse because you want to make sure that you are in the correct folder here. And mine was on my desktop. So I'm going to go to my desktop and I'm going to go to mixed ANOVA that I just pulled. And then I'm going to go ahead and then select open. And then I'm going to make sure that all this is starting in a new project session. And then I'm going to select create project. Okay. So give it a second, 1 second. Awesome. So I expand that new project into a large window. And now I'm going to create my script file. All right. So to do that, I need us all to navigate to that top menu bar and then click File on the left-hand side next to RStudio. A drop-down menu will fall. Please go ahead and select New File, followed by, let's just use an R markdown for this. We're going to type out our title that's going to go within our document itself, our deliverable itself. And I'm just going to type out mixed ANOVA. All right, the author and then today's date will be there, and then along with the different output formats that are available for you to use. I'm just going to go ahead and I'm just going to leave the default of an HTML here. But if you want, you can go ahead and select PDF or Word for your deliverable. And then I'm going to go ahead and I'm going to hit OK. Perfect. Once I do that, I need to go back and I need to make sure that I save this new script file that I'm going to be typing in all of my code. Okay, so I'm going to navigate back up to that main menu where file has then appeared. I'm going to select file and then from there a drop down menu will fall. I'm going to navigate all the way down to save as because I want to save this new R script as something. So I'm just going to type out mixed ANOVA, and then save. Okay. All right, so before I actually get started in actually using our QMD file or HTML file that I have given to you, if we can go ahead and move a couple things around, the first thing that we're going to move around is our data set that we are working with, and it's titled Burnout. And let me show you how I'm going to do that. I'm going to go back to my desktop here. I'm going to pop open that file that I have that I downloaded from GitHub. And then I'm going to move this file called burnout.csv into my new working directory. So I'm just going to pull it over. I'm just going to drag and drop, and it was titled Mixed ANOVA. And there it is, along with my R project and my new RMD file. Okay. And so I'm going to just triple check everything worked out by navigating back to my Mixed ANOVA RMD file, back to my working directory here. And I can see now that burnout is there. Perfect. Another thing that I'm going to do is I'm actually going to split screen between my RMD file and the HTML file that is in the folder that you downloaded originally. So let me pop that open. I love to follow along, and this is how I do it. Okay. So HTML file, the HTML file will pop up. All right. And so let's move this over. Our studio. Cool. All right, I am ready to go. So, as I previously noted, we are going to be reviewing how to apply a mixed analysis of variance. So, a mixed design of an ANOVA with two factors. One within subjects factor that measures the change over time within individuals, and a between subjects factor that identifies differences based on group, treatment, condition, characteristic, and how to evaluate their interaction. So a mixed model or mixed design ANOVA tests whether each of the three effects, the two main effects, and their interaction are statistically significant. And so we're going to be relying on a study done by Yan et al. This is actually a review, a literature review on current large language model chatbots that are used for workplace therapy. And we're going to evaluate the difference in workplace burnout pre and post therapeutic approach, including a hypothetical LLM chatbot and an in-person therapy condition. Okay. So a little bit more about our study here. In this study, we're going to explore the effectiveness of two different mental health therapeutic approaches aimed to really try to reduce the feelings of workplace burnout in 60 employees over time. So we have a between subjects factor that includes a 30-minute session with Ruby, which is an LLM chatbot, or an in-person therapy. So those are my two conditions. One more time, I have two conditions for my between subjects, and that is either an LLM named Ruby or an in-person therapy session for 30 minutes. My within subjects factor includes actually three conditions. This includes the beginning of therapy assessment of burnout or feelings of burnout, a midway assessment of workplace burnout, and then an at a discharge assessment of workplace burnout. All right. So, the thing that we are technically really focusing on here is going to be our interaction. It is really important. This is what we want to see or we want to evaluate. So, this is one of the first hypotheses that I hope that you all generate. And so, the null would suggest that there is no significant interaction between the therapeutic approach and time conditions on the reported levels of workplace burnout, versus what our alternative would suggest that there is a significant interaction between therapeutic approach and the time conditions on reported levels of workplace burnout. And so then following would be our within and then our between main effects. So whichever comes first, but I do want you to know that we are most concerned about the interaction and the patterns that we are going to be seeing due to that interaction. Okay. Our within subjects mean effect would then suggest that there are no differences in employees' reported workplace burnout across time, such that T1, T2, the means rather of T1, T2, and T3 are all the same. However, the alternative would suggest that they are not the same, that we are getting reported differences of burnout across time, or that there are mean differences across time. Our between subjects effects, one more time, this is focusing specifically on the therapeutic approach. And our null would suggest that there are no mean differences in employees reported workplace burnout based on the therapeutic approach that they end up getting. While the alternative would suggest that there are mean differences between therapeutic approaches and reported workplace burnout. You can see that I have nothing to do with time here. I have nothing to do with interaction. I'm just focusing on the therapeutic approach effect here. All right. All right, so let's just get straight into it. What I need you all to do, if you could simply copy all of these packages that you are going to need. I have put in the really cool option of being able to copy this code by using the copy to clipboard function here. So go ahead and select that little clipboard for yourself, and then go ahead and then paste it into your own RMD file. How we're going to do this is that we're going to start a new R code chunk. So for my Mac users, Option Command I. All right, Option Command I. And it's something very similar for my Windows users. All right, and then go ahead and leave yourself a message such that you are going to upload packages or run packages in this article and chunk. Always leave yourself as many little tidbits as possible. The more little messages that you have for yourself, the more that someone else can go ahead and follow along, helping with reproducibility. All right. And so I'm just going to paste all of those packages into my R code chunk here, and then I'm going to run it. So you can either use a play button or you can go ahead and run line by line. I'm just going to use the play button to run this R code chunk. Okay. For my folks out there who don't already have these packages, what you need to go ahead and do is you can use the install.packages function. And then within the parentheses there, I need you all to put in quotes the package that you want to go ahead and install onto your computer here. I don't want you to run it in the R code chunk itself, but please go ahead and do it within your console. That is the easiest way to do it. So that way, whenever you are rendering or saving this file, it's not being run over and over again. Okay. I'm just going to move out of this message. All right. So now we can start going into data exploration. And so we are always going to look and explore our data before moving on to any type of analyzing. So I'm going to first start off a new R code chunk here. I'm going to write myself a note by hitting Shift and then pound for a new note to be generated here. So I'm just going to write out data X exploration. Another little tidbit here is that you can always add a title to each R code chunk. For instance, you can type out data exploration, and you can see now that this R code chunk has a title. All right. So you can do that to every single one of your R code chunks. I love doing this. It just makes it so easy to navigate. You can also use the outline if you need to by leaving yourself some headers there. I'd like to use 2 pound signs, and then this is how you get your outline generated. Okay. There are different levels that you can use by implementing different number of pound symbols there. Okay. All right, so here we go. So the first way that we are going to get everything started is that we are going to call in our data, our burn.csv file in. And so you can do that by typing out read underscore CSV, and you can see that it automatically generates. And then within quotes, go ahead and type out burnout. And I know that I will be able to call in this data file because it is in my working directory, how we set that up earlier. And then you can go ahead and hit equal, or you can do an assign symbol that I have within the HTML file here. It is up to you. I like to use the equal sign sometimes. And then I'm just going to type out burnout to give my data some sort of name within my environment here. Okay. So I'm just going to then run that line of code. I'm going to hit command enter. And I know for a fact that I went and hit and I called in a data set because it is now in my work, in my environment, my first panel there. All right. And then I want to just look at my data. It's so important just to look at the data to see how it is read in. And I can see first thing that I notice is that I want to get rid of column one. I want to get rid of column one. It's a duplicate of what is already generated by R when I call in data. So I'm going to remove column one. And how I can remove column one is by typing out burnout. And then I'm going to use, since this is my data set here, my data frame specifically, I'm going to go ahead and use brackets. And then I'm going to type out a comma, and then I'm going to use a subtract symbol or a minus symbol, and then one for column one. So what's happening here is that the reason why I put a comma is because within the brackets, it reads a bracket as RC, meaning row and then column. So row comes before the comma, and then after is the column. So that's why I'm saying column one. Right. And then I want to assign this back to burnout. Burnout. All right. I'm going to run that line of code. You can highlight it. You can just uh, see at the end of that function there and then hit command, then return. All right. And then I'm just going to go back and I'm going to check the data. I want to see what it looks like. Did it actually work? And it did work for me. I no longer have that first column of repetitive numbers, right? It's just not necessary. Another thing that I'm noticing is that I have an ID column, which is what you are going to need for the setup of a mixed ANOVA, because I need to remind you that folks are being tested across time, 3 time periods. That means this ID person, number one, is tested 3 times across time, and they're given the same treatment, Ruby, only Ruby. And their burnout is also reported across these 3 times, and given that they had the treatment Ruby. All right. So that's how your data needs to be set up prior to uh, analyzing the data. I'm going to leave myself a note here on line 31 saying that I had removed column one. All right. And then I'm going to then just take a look at some sort of basic descriptive statistics. And then I'm just going to type out reviewing data. Always leave yourself a message by adding a pound symbol and then your message or your note after that. I'm going to be using the skim function. I showed you all this in another video before. I love the skim function. It just gives me basic descriptive statistics. Along with missingness, I always know that I have to deal with missingness even before I get into any type of analytic approach. So I really do enjoy this function here. All right, so I'm going to type within skim burnout because that is the data frame name, and then command return. And then I can go ahead and run that function. And then I get information related to my related to my data set here. And it'll give you everything from missingness to complete rate to your mean, your standard deviation, along with those different quantiles. Okay. You even get like a distribution type of presentation there at the end. All right. So that's great to have. I really, when I'm working with any type of group data, I like to break things down, meaning I like to get my means, get my standard deviation based off of group. And in this case, I don't want to do it by time, but rather I want to focus on the groups, and then time will be my second factor that I'm most worried about. So let me show you how I like to do this, okay? So I am going to uh, type in a new R code chunk, burnout, because this is the data set that I'm working with, burn out. And then I'm going to use a pipe. So that's Shift Command M. And then I'm going to type out group underscore by. This is the function that I love using, group by. And this is what helps me get those summary statistics based off of a group. And in this case, I have a treatment group that I'm concerned about, right? That's my main priority. And then I have time. Now, the reason why I have it set up this way is because I want my treatment to come first, and then I want my time to come second. Okay, and then I'm going to use another pipe again. So Shift Command M. And then I'm going to use the summarize function, and that'll automatically come up because it's in the dapplier package there. And then within this summarize function, I want to have a mean underscore burnout column. And then I want that to equal the mean of burnout. And then I'm going to finish that off with a comma. And then I want my standard deviation. So I'm going to call this column SD underscore burnout. And then it's going to be equal to the SD and then burnout again. And then comma. And then another thing that I'm going to do is that I don't want my groups to be then and analyzed further on in this group way or in given groups. So I need to make sure that I drop this whole group grouping that I'm doing here. So groups equals and then drop. Cool. And then I need to make sure that I close out this whole entire function by making sure that I have the end of my parenthesis there. Now I'm going to run this R code chunk. I can stay on line 46, hit command, and then return, and all of it will then be generated. All of it, what I mean is the means for each one of these treatments and over time. And I can see my means followed by my standard deviations. I'm going to need this information later on when I'm reporting information about my mixed ANOVA findings. So this is why it is so handy for later on. So one more time, keep this in the back of your pocket. You're going to need this for a write-up. Prior to actually implementing ANOVA on these two factors and looking for an interaction between them, we are going to be evaluating several assumptions. And one of the first assumptions that I do have to talk about, but we actually don't get to analyze with any statistical technique, is our assumption of independence of observations. And what this assumption suggests is that our observations are only assigned to one treatment group. Although we are not, one more time, analyzing using some sort of code in R, it is very important that you understand your study's design and making sure that folks only got to be exposed to one treatment. All right, so I'm going to move on to our next assumption, and that is the normality of residuals. The normality of residuals. And so what this suggests is that our residuals are normally distributed. So if you don't remember what residuals are, just quickly, residuals represent the variance that is not explained by a model. And it suggests that there is some sort of difference between the line of best fit and our actual data. Another way that we can say this, it's simply the difference between the predicted values from our model and the actual data points, because no model is ever going to be perfect. There's going to be some sort of residual. We just don't want that residual to be large across these different values, okay? And we want our residuals to be normally distributed across that whole predicted line there. So to ensure that our residuals are normally distributed, we can go ahead and evaluate them using things such as an histogram or a QQ plot. And that's exactly what we are going to be doing. Now, to do this, I need to go ahead and implement a new R code chunk in my RMD file here, Option Command I. And so I am going to extract my residuals by pulling them out of my LM or my linear model findings. And so how I can go ahead and do that is first I'm going to type out that I want my residuals. So residuals, and then I'm going to go ahead and hit return. And then from there, I want my residuals to come from my linear model that I'm going to be running between burnout, treatment, and time. So LM, and then I'm going to type out LM and then open parentheses. And then I'm going to then type out burnout and then a tilde and then treatment multiplied by time, then comma, and then data equals burnout. I'm going to assign this to an assignment here, or to an object here rather. So I can type out equals if I wanted to, or I can type the assignment, whichever you prefer. I'm just going to hit equals since I'm already here. And then I'm going to have this object be named residual or res. Okay, I'm going to run this line of code. I know that it has done its job because there are values in my environment here. All right, there they are. Here we go. So my residuals are in my environment, and then I want to go ahead and visualize them. Okay. Leave myself a note here. Don't forget to leave yourself a note. So shift and then pound symbol, running an LM to get my residuals. All right, on line 52, I'm going to hit a return to move on to line 53. I'm going to write myself a comment here, visualizing residuals using histogram. All right, and then return, and then on line 54, I'm just going to type out hist. This is built into R, so hist for histogram, and then res for the residuals that are in my environment there. I'm going to hit command return after that, and then you can see that these residuals are normally distributed. Great. Since they are, I am going to have somewhat a little more confidence in that I am meeting the assumption of normally distributed residuals here. And when I have that confidence, I can then be a little more confident in my p-values and my confidence intervals that I'm going to be getting out of my ANOVA. One more time, if we don't meet this assumption, there is actually a possibility that we can be making a type 1 error. And we just don't want that, right? Because then it suggests that there's a lot of noise or a lot of variance not left explained by my model itself. Okay. Another way that you can go ahead and take a look at whether these residuals are normally distributed, you can produce what is also known as a QQ plot. All right. And so I'm just going to go ahead and implement a new R code chunk option command I here for my new R code chunk, writing myself a note QQ plot for residuals. And then I'm going to be using two lines of code that need to be put together. So first I need my QQ norm and then residuals or res for the name of my residuals that are in my environment, followed by QQ line. And then res for those residuals. Okay, so what these two different lines of code are doing, one is plotting the actual residual, rather line 59. The first line is plotting those residuals across these theoretical quantiles. And then the QQ line res is actually giving me that line itself a best fit. So you need to run these two together. Okay, because if you don't, you're just going to get your residuals plotted without that line. And so you want that QQ line actually plotted against it. So you can determine whether really these residuals are normally distributed. You want them following that line very well. And we do, we have that here. All right, moving on to our next assumption here, and this is the homogeneity of variance, which suggests that the variance is technically equal across both treatment groups. One more time, homogeneity of variance, homo means same here, same variance across my two different groups here. So each group will have their own mean, but the variation among these subjects should be approximately the same. So I'll say that one more time. They're both going to have their own mean. They should. We are concerned about the differences in mean, but what there should not be a difference is the variation around that mean. Right? We don't want one group to have more noise than the other because that one group that has more noise could then influence our findings here. And we just don't want that. By not actually meeting this assumption, once again, we are inflating type 1 error. And so for us to go ahead and evaluate whether we have met this assumption, I'm going to be relying on Levene's test of equal variance. And so the null here suggests that, or if our p-value is greater than 0.05, means that we actually have met this assumption, suggesting that the variances are equal. So the assumption of homogeneity of variance is met if our p-value is greater than 0.05. The alternative would suggest that at least one group has some sort of mean difference, and then we wouldn't technically have met the assumption of homogeneity of variance. Okay, I do need you to know that slight deviations, very slight deviations, are robust. I mean, meaning that ANOVA is robust in the presence of slight deviations of homogeneity of variance. All right, so let's just do this. I'm going to implement another R code chunk here, option command I. I'm going to leave myself a note in this R code chunk, shift pound or shift 3. And then I'm going to write down that I'm using Levene's test for homogeneity of variance. So I'm using the Levene's, let's see, Levene's test, and it should be the one with capital in my car package. And then I'm going to first type out burnout and then tilde, oops, and then treatment, comma, data equals burnout data. Let's see. Burnout. There it goes. Okay. So let me run this real quick. Treatment. I apologize, everyone. Running this. All right. And so the first thing that I notice here is that I typically am meeting homogeneity of variance. I don't know if you can all see that little dot right there, but that is suggesting that I am approaching significance, but rather that I'm technically still not statistically significant. One more time, my p-value is actually greater than 0.05. I have met this assumption of homogeneity of variance. I'm just going to write myself a note stating that I have met it. So write yourself a note within your RMD file. All right, moving on. Now, this next assumption is by far the most important assumption out of all of them. This is the sphericity assumption, and it's actually aimed to evaluate any variance of differences between time points because they should be equal. And that suggests that meeting this assumption is important because we are comparing time point variances to one another. For instance, it's me comparing the variance of or finding the difference between time one and time two's variance, and then comparing it, for instance, to the difference between time one and time three variance. And so we want those differences to be very equal to one another, as close as possible. If there are differences in those pairs of variances, that's going to suggest that we may actually have a higher chance of type 1 error and bias within our findings. Now, to go ahead and to try to figure out if we have met this assumption, we are going to be using another test, a test of sphericity. And so there are different types. We're going to be using Mauchly's test. And so let's go ahead and implement this. I do want you to all know that if we have a p-value that is less than 0.05, we technically do not have variances that are equal to one another. And then from there, you would use either a greenhouse gazer or a Huon and Flit approach to deal with those violations. Okay. So one more time, we're aiming for a p-value that is greater than 0.05 for this test of sphericity. All right. And so then let's go ahead and create a new R code chunk. All right, create a new R code chunk. We are going to be running the mixed ANOVA. I do want you to know by running these next lines of code, you are going to actually get your ANOVA findings and you're going to get information regarding whether you have met the sphericity assumption. Okay. And so one of the first ones that I'm going to use here, because there are different functions that you can use to run a mixed ANOVA, we are going to be using the easy ANOVA or AOV easy. And so how we can go ahead and do this is by first typing out the function AOV underscore easy, because it's supposed to be easy to run this, supposedly. And so you want to first type out that you have your IDs because you have repeated within measured design here. You need those IDs. So ID equals ID because that's the actual name of it. And then you want to follow that up with a comma. And then you want to then type out DV for your dependent variable. What is the outcome that you are interested in? And in this case, ours is called burnout, comma. And then you want to know your between subjects condition equals treatment. This time I'm going to spell it correctly, comma. And then your within is going to equal time. Okay, comma. And then your data in your working environment over there is called burnout. Okay. And then we're going to be closing this with a parenthesis. There it is. All right. And so I'm just going to run this first. So the thing that you could use is the play button there, or you can go ahead and run it by doing command return at the very end on line 77 if you like to. And then you could see here that we actually get our information related to our ANOVA that we have just created. I do want to go ahead and assign this all to a object. So I'm just going to type out equals here, and then I'm going to type out ANOVA model. Okay. And then I'm just going to rerun that. I love how it converts our factor treatment in and it creates a contrast for us automatically. This is what I love about this assumption. Another thing I'm going to show you right now, I'm going to use another R code chunk here. And then I'm simply going to type out or copy ANOVA model because that is the object that I have assigned our model to. And I'm just going to run that. And you're going to see that, let me see that first of all, this particular function automatically corrects for any types of violations related to sphericity. And it tells you which correction method it ended up using because it could use either one of the correction methods. And in this case, GG stands for the greenhouse geyser approach. All right, so GG, we applied, and we can see here the first thing that our interaction is actually significant. Our interaction is significant. This is what I would first report. This is what I am most concerned about. So I would report that. All right, so I do want to show you the other functions before we move on. All right, so let me show you how you can use the ANOVA underscore test. This is in a different package. So Option Command I. And so then I'm going to first type out burnout because that is the name of my data set here. Okay. And then I'm going to use a pipe shift command M. And then I'm going to type out ANOVA and then underscore test. This is in my R statistics package here. And then you can see it automatically generates. I'm going to hit return. And then after I hit return, I'm going to type out DV equals burnout, comma. And then I'm going to say WID for my ID is going to be named and it's titled ID within my data set, comma, within equals time, comma, and then between is going to be treatment. All right, cool. Do I have everything? I think I do. All right, I should be able to run this and we can see that I get findings. Our findings here just look a little bit different. I do actually prefer this function versus the function that I used before, the AOVEZ. And the reason why is because I specifically get my Mockley's test for sphericity information here that I can go ahead and actually end up reporting in my write-up. I do prefer this. And then it also does a correction for me as well. And it does it separately from the ANOVA without corrections. So here I have without corrections, and then I have my test for sphericity, followed by the correction to those estimates there to my degrees of freedom, and then I have my information produced there. All right. So because I already know, given that both of my analyses here, depending upon which function I'm using, they both technically tell me exactly the same information, suggesting that I do have an interaction between treatment and time. This is when I would then follow up by looking and evaluating for differences among my treatment versus condition. Where are the significant means at? And so what I can go ahead and use is the EM means function. So EM means function. This is in the EM means package. You can also use the R statistic one, but I'm using this one here for the easy ANOVA function that I have there. So EM means, and then I'm going to type out ANOVA and then model. All right. And then I'm going to hit comma, and then I want my pairwise. Pairwise. And then I'm going to go ahead and have a tilde and then treatment by time. So treatment and then by time. All right. Let's see. And there I go. Now I have my EM means here, and you can see that you are given the means along with the standard error, along with the lower and upper confidence intervals as well. And then you also have some degrees of freedom reported. The thing that I am most concerned about here are my contrasts. My contrast will actually tell me whether I have significant differences and where those differences are significant at. And so I can see for my time one here, my in-person therapy versus my Ruby, that that the burnout between the treatments are not significant for time one. For time two, I can also look if there are significant mean differences in reported workplace burnout between in-person therapy versus the Ruby, and it's not. That p-value is greater than 0.05. When I move to time three, when I'm looking at the difference, reported mean difference in workplace burnout between my in-person and my Ruby, there actually is a significant difference at that point in time. All right. So, one more time. In my ANOVA findings, I am given a correction for sphericity and whether I have an interaction and a main effect. So the time is there, the treatment main effect is there, and the interaction is there for my general ANOVA. And then I'm given the Mockleys, and then I'm given a correction there. And the same thing goes for my basic easy approach to my ANOVA. You can see that the treatment, the time, main effects are there, and then their interaction. And one more time, these values should be the same. This first approach gives me automatically the corrected values versus my ANOVA underscore test by the R statistics gives me first the uncorrected, then the sphericity test, and then the correction. Just making sure that that is very clear there. All right. Now, how we would go ahead and write something up is that we would kind of say the following. A mixed a mixed design ANOVA was conducted to investigate the effects of mental health therapeutic approaches, Ruby versus in-person therapy, and time on workplace burnout. Prior to evaluating the interaction of mean effects, assumptions were evaluated. Mockley's test indicated that the assumption of sphericity was violated, and I ended up getting a chi-square along with a degrees of freedom. Let me show you where I would get this information from. So I would first go back up to my test here. One more time, this is why I prefer the ANOVA underscore test function because it gives it gives me the sphericity test here. All right, and it gives me a value. And we want to go ahead and use that value there. And then for my for this degrees of freedom here, I would go ahead and use my and go ahead and I would use my my number two, right? Because I have technically I'm going to be using this for the treatment versus the time. So two. And I would note that it was less than zero point 0.05 there. And so then that would give me the indication that I went ahead and I used a greenhouse geyser corrected result and how it's reported below. So results suggest that there was a statistically significant interaction effect between treatment and time with the F value. Let me show you where I got my degrees of freedom. It's under the corrected sphericity information. And so I would go to degrees of freedom, so DF and then GG within those brackets. And it's the values here of 1.57 comma 913, 91.3. So that's how I went ahead and I found those values. You will find the same values reported up above in when I use the AOV underscore easy. So 1.57, 91.3. All right. And then I would note that they are that is statistically significant with an F value of 71.65. And so that would also match down below. And then I would go ahead and would report where those values were significantly different, where the means were actually significantly different. It was at time three. So at T3, the in-person therapy group reported substantially lower burnout, 51.7 with a standard deviation of 9.22 compared to Ruby group 64.5 with a standard deviation of 8.86. Where did this information come from? Where did these means come from? Well, it came from all the way back on top when I went ahead and started exploring my data there. And so one more time, I told you to keep this handy dandy in the back of your pocket. So I literally went to Ruby and I looked at time three and it was 64.54 and then my standard deviation along with my in-person time three mean and my standard deviation. All right. All right, thanks for joining me today. I hope this video was useful for you so that way you can go ahead and apply a mixed designed ANOVA next time. If you have any questions, go ahead and reach out.